I asked you all to do 1 through 6. Did we have any questions on them? Okay, the only one I want to talk about is 6. 6, we have 3 items being multiplied. You cannot multiply all 3 at the same time. So you got to pick 2. So maybe you opt to multiply these 2. If you were to do that, you would get negative 14r squared, add 12r, add 12. And then we have 2r minus 4. Now you would multiply again. So you're going to multiply this by both terms, that by both terms, so on and so forth. This should have been reviewed. Was it? For the most part? This question at the top, for all of these problems, what operation are we performing? Multiplication. Can you write that down, please? For all of them, we are multiplying. That is not the point today. That was a review. The point today is working backwards. So figuring out when we get an answer, how do we work backwards to get its factors? Okay, so we are going to work backwards a little bit, and then we will take a break. So what I want to do is I want to take an expression like I have in 7 and get to the terms that multiplied to get to it. If I look at the numbers first, what is the biggest number I can divide 12 and 18 by? 6. 6. Okay, and when I do, if I take 12 and I divide that 6 out, I'm left with a 2. When I take 18 and divide the 2 out, I'm left with a 3. Now, if I look at the V's, I have 2 V's here and 1 V here. If I want to divide something out of both, I have 2 V's I can divide out of the first term, but only 1 I can take out of the second term. So in total, I can divide a V out. And I'm dividing a V out of both terms, which means the first term leaves me with a V, and the second term does not. So what we did is we divided out 6V and figured out what was left. Now, to check or to show that that's the correct answer, we can multiply it again. So we're going to do that real quick. 6 times 2 is 12. V times V is V squared. 6 times 3 is 18, and then we have a V. So we got back to where we started. That shows that our answer is correct. But to clarify, this is our answer. So we are looking to get to the point where we can take out the biggest quantity. Does this look familiar? A little bit, maybe, for some of us? Okay, we're going to do a few more together. I'm just going to go down the line. For 10, is there a number I can take out of both of these? A 1, which I don't really need to write. This first one has 2 n's. The second one only has 1. That means if I want to pull something out of both, I can pull an n out of both. So this n is gone and that n is gone. This is where we need to be careful. I'm left with an n. Remember, we are dividing out. So if I had an n and I divided out an n, what am I left with? N, divide out n, you're left with a 1. That's what most people forget, is the 1. Now check your answer. Make sure it works out. Multiply in. We get n squared add n, which was good. Okay, 13. What can I take out of 9 and 6? 3. So when I do, I'm left with 3 and negative 2. If I have 3 p's here and 1 p here, how many p's can I pull out? 1. If I have 3 here and only 1 here, I can only take out 1. Now, when I take out 1, I got to think. I had 3 here. I divide 1 out. How many's left? 2. I had 1. I divided that 1 out. So that's it. I lied. We're going to do one more together. We're going to do 15. And then I'm going to give you some time to work on this. Okay, 15 for 2 and 2. I can take out a 2. Manny, are you answering?
No, I have a question for 13.
Sure.
Why couldn't you do 3p squared on the outside?
Because this one only has 1 p. So there's not 2 p's for us to take out. 15. We can take out a 2. Out of x to the 5th and x to the 4th, what is the most I can take out of both? So I have 5 x's, and I have 4 x's. What can I take out of both? 4, right? I could take 2 out of here and 2 out of here, but I would still have 2 left. So ultimately, I can take 4 out of both. When I do, I'm just left with 1x. And then if I have 2x to the 4th and I divide it out 2x to the 4th, what am I left with? 1. How do we feel about that? Okay? Any questions on this, which we've done so far? No. Okay, the big question then is how do we work backwards when we need to get something like that? So it's easier when we have something like 7 where we're just pulling out a term. But how do we end up with 2 factors like in number 3? So I want you to go to the next page. So that is something like 16. So we're going to talk about 16 together. Is there anything I can take out of all 3 of those terms? Is there anything that n squared, 10n, and 9 all have in common? No. Okay, so there's no GCF. There's no greatest common factor to take out. That tells us that we might end up with 2 factors like this. Okay, I need you to listen. This is really important. I'm going to teach it to you a little bit differently than what you did last year. Some of you did not do this at all last year. Here's what I do. I think about n squared. How could I get that? There's only one way to get n squared, and that is n times n. Then I look at the back. How could I get 9? Well, there's a whole bunch of possibilities of how you could get 9. The first one that we probably think of is 3 and 3. So this is called guess and check. So we now have to ask ourselves, is this going to work out if we multiply? If we do n and n, we get our n squared. That's good. 3 and 3 gives us our 9. We're going to end up with a 3n and a 3n. Does that work then? No. What are we aiming for? Negative 10n. That didn't work out then. Okay, so we try again. We have n and n. We know those are our only possibilities. Now, if we're getting a negative 10 here, do you think a positive number and a positive number make sense? No. Right, because positive and positive are always going to add to be a positive. So we need some negative numbers. So we might try next negative 3 and negative 3. Is this going to work out? No. We're still going to get positive 9, but now we get a negative 6 and a negative 6. That doesn't work. I'm sure some of you have come up with it. What are the 2 numbers that do work? What other numbers multiply? 9 and 1. Okay, so 9 and 1 do in fact multiply to 9. Avery, positive or negative? Negative. Right? And then you're going to have to verify in your head. We get n squared. We get positive 9. we get a -1 and a -9, which gives us -10n. So this is called guess and check. This is the way that we are going to be trying to do these problems. We are going to do a few more. I would like to do 20 and 21 with you, and then I'm going to give you some time to work. If we look at 20, the very first thing you have to do is ask yourself, is there anything in common? No. Is there anything in common between all three of these? No. I will tell you, though, I don't like a negative. So what I will do, personally, is I will factor out a -1 so that I don't have to deal with a negative. When I do that, I get n squared, subtract n, subtract 56. Now, the reason I don't like that negative n squared is because I know n squared is just n times n. That's a lot easier. Now we're thinking of numbers that multiply to -56. What are two numbers that multiply to 56?
8 and 7.
8 and 7. If I do +8 and +7, am I going to get -56? No, right? So one of them has to be negative. So maybe I try to do +8 and -7. Does that give me -56?
Yeah.
Yes. Will it give me a -n in the middle? No. What will it give me instead? Positive n, right? I'm going to get 8, and I'm going to get a -7, which gives me positive n. So what does that mean we need to do? Flip the signs. So we have a -8, and we have a +7. And then we have to remember this negative out in front. Now, if we FOILed this out, we should get back to where we started. How do we feel about this guess and check idea? Not too bad? Can we do one more together? Question 21. What do you notice about 21 that's different from the others? Yeah. Okay, exactly. It's not in standard form. Do you notice that the squared is at the end? Okay, so let's start by putting it in the correct order. It should go highest power to lowest. So we have 3z squared minus 15z, add 18. Okay, now I have to figure out what I can take out of all of those. 3. They all have a 3 in them. AJ, if I take a 3 out of every term, what am I left with?
Z squared minus 5 plus 6.
Okay. So now, if we're doing some guess and check, the only way to get z squared is z times z. If we need our numbers to multiply to 6, positive 6, what does that mean about our two numbers? What does it mean about their signs? They're going to be the same, right? Both positive or both negative. Two numbers that multiply to 6, for example, 6 and 1. Does that work out? No. What would we end up with as our middle term? Positive 7. Okay, so not only did we learn that 6 and 1 don't work, what did we also learn that we are going to need? Are two positive numbers going to work? No. Two negative numbers. So we could try -6 and -1. What would that give us in the middle term? -7. So that doesn't work. This doesn't work. So what are the two numbers that do work? 2 and 3. And it doesn't matter the order. I'm going to cross this out too so we know those numbers were wrong. Okay, do you have any questions for me? Okay, I'm going to give you 10 minutes to work on all the problems up until 21. So go back to 8, because that's where we left off, or go backwards, I don't care, but you should stop at 21. You have 10 minutes. If you have questions, let me know. Okay, Last thing that we are doing is we are solving. Last thing we are going to do is we are going to solve. Can you flip to the next page? I'm not going to because it doesn't work so well with my page. But what do you notice for the problems on the third page compared to the problems above? There's an equal sign. Okay, so write that down. There is an equal sign. Now, I think in math, a lot of times we use words and we don't talk about what they actually mean. So I want to talk about when we solve an equation or we find a solution to an equation, what does it actually mean? So let's look at this example C down below. We are solving this equation. If I were to solve that, what's the first thing that I'm going to do? What am I trying to do? What is my goal? If I say solve that equation, what's my goal? Okay, find an answer for what? For x. So I need to get x alone. So what I'm going to start by doing is adding 3 over 2x to the other side. So please do that. So we get positive 3 over 2x equals 6. How do I get rid of that 3 over 2? Multiply by the reciprocal. So 2 over 3. So those go away. How do I take 6 and multiply by 2 over 3? Make it a 6 over 1. Multiply across. So I get 12 over 3. And what is 12 over 3? 4. Okay, so please write this down for me. What we just did is we found the number that makes the equation true. So if I were to take this 4 and plug it back in, that equation would be true. Now, what I also want you to notice, though, is this graph that you see on the left. So I want us to notice that this negative 3 over 2x plus 6 is the same thing on the left. Is there anywhere on that graph that you see this 4, this x equals 4? Where? Do you see that that's where it intercepts right here? What axis is that, the horizontal axis? X-axis. So on a graph, what we do is we found the x-intercept. And that is where our graph intersects the x-axis. So when we say solve, there's 2 things that we're doing, as we can see up here. One thing is we're finding the number that makes the equation true. But what we're also doing is we're finding the x-intercept. So anytime you see solve, you should know it means 2 things. That number makes our equation true, but it also, if we were to graph, is where our graph crosses the x-axis. And then I have one more question for us. Next page. Okay, last question I have for us is this question at the top. If the product, what does product mean? No. Multiplication. So if we multiply 2 numbers and we get 0, what do we know about those 2 numbers? One of them is 0. On the other hand, if I take A times B and I get 8, let's say, does that mean that A is 8 or B is 8? Does it have to be that one of them is 8? Can you think of 2 numbers that multiply to give us 8 that don't include 8? 4 and 2, right? 4 times 2 gives us 8. So that example just shows us that we can't say one of our numbers is 8. But on the other hand, if we got 0, is there any way to multiply 2 numbers to get 0 without having one of the numbers be 0? No. Okay, so that is really, really important. Write this down. It's called the zero product property. Okay, we are going to do a few examples from the rest of this page, and then I'm going to give you the rest of the time to work. If we look at 22, the first thing that you're going to do, because of this zero product property, is you're going to make sure your equation is equal to 0, which it is. And then we're going to try to factor. Is there anything that goes into all three of those numbers or all three of those terms? No. Okay, so now we're trying to come up with our factors. To get b squared, we get b times b. To get our numbers to multiply to positive 8, what do we know about the signs of our two numbers? If they need to multiply to positive 8, they need to be the same. So they're both positive, or both negative. Jacob, that negative 6b in the middle, do we think we want two numbers that are positive or two numbers that are negative? Two negatives. Okay, so give me two negative numbers that multiply to 8. 4 and 2. Okay, now check. Does this make sense? B and B gives me b squared. Negative 4 and negative 2 gives me positive 8. I'm going to get a negative 4, a negative 2, which is negative 6b. We good so far? Okay, what this is saying then, this b minus 4 is some number. This b minus 2 is some number. And when we multiplied them, we got 0. The only way that that would happen is if that b minus 4 equals 0, or if the b subtract 2 equals 0. That's the only possibility. So we get b equals 4, and we get b equals 2. Now, if you plug 4 into your equation, you're going to get 0. If you plug 2 into your equation, you're going to get 0. That's how we would verify these. I want to talk, though, about what these mean if we were to graph. Do we know what something squared looks like as a graph? Do we know the word for it? A parabola. I don't know if you guys saw that last year. Can you draw this with me? It is a U, yes. So b squared, when you see a squared, that's going to be a parabola. So it's going to look something like this. And so when we find these numbers of 4 and 2, we are finding these two numbers right here, where our parabola crosses the x-axis. So that's the meaning of those. Can we do 2 more? You guys okay with that? Okay. We're just going to go to 25. Zero product property means we need to be set equal to 0. We're not. So don't factor until you're set equal to 0. So I'm going to subtract 60. So I get negative 2k squared, subtract 22k, subtract 60. First thing always, is there anything in common between these three? Negative 2. So make your life easier and take that out. Be careful with your signs. We're going to get k squared, add 11k, add 30. Right? Does that look right? Okay. So we are looking then for two numbers that multiply to 30. Positive 30. So what does that mean about our signs? They're the same. Both positive or both negative. What do we think if we have a positive 11? Both positive. Okay. So we have 3 and 10. Would 3 and 10 work? 5 and 6. So if we do a mental check, I would get 5k, 6k, which gives me 11k. So that works out. Okay, so we set both equal to 0. K add 5 equals 0. K add 6 equals 0. So that means that k is equal to -5 or -6. So again, those are the only values that make this equation true. These are the only two numbers that make this equation true. And then if we were to look at our graph, this is where our graph crosses the x-axis. How do we feel about this? We're okay? Okay. Do you all want time to go from here? Okay. I will tell you, at the bottom of this page, I did put 2 geometry problems. You might want to start with those just because they involve a little bit more setup.